So let's start. Well, in the previous class, we had discussed about arrays, and and the class after that, I had discussed about the program that you had that had been given to you. So today again, we'll be talking about arrays. We will basically be talking about three things today. So today's topics are as follows. So at first we are going to talk about the concept of arrays. This is just a revision of the previous class. We'll be talking about the concept of arrays. The new thing that I'll be talking about today in this particular topic uh, is an analogy of arrays, using some real world object. So using an analogy or an example of a real world object, so that it's much easier, so that it becomes much easier to understand how arrays work and what exactly are arrays. So we'll be taking the example of a real world object. The second topic that we are going to do today is the for each loop. This is basically a variation of the default for loop. So this variation is principally used in case of arrays, with arrays. So we'll be talking about the for each loop, which is a variation of the for loop. And the third thing that we are going to talk about, if we have enough time, that is searching in an array. So searching is a pretty easy concept, and it's pretty easily done using arrays. So the third topic for today will be searching in arrays. Okay, so let us start with the first topic, which is the concept of arrays. So again, the question is, what is an array, right? So this is the question. So to better understand what is an array, consider boxes. Consider a row of boxes. So I'll be taking some time to draw the boxes. So okay, let's not draw it in this way. Let's draw it, let's not draw 3D boxes. Let us draw normal 2D like boxes. So just imagine that these are, boxes. So this is a row. So this is a row of boxes, and so the first thing is, this is a row of boxes, and the second thing is, each of the box is labeled. So the first box is labeled 0, the second box is labeled 1, third box is labeled 2. uh, Let me write it outside the boxes just to avoid confusion. So the first box is labeled 0, the second box is labeled 1, and so forth. So an array is nothing but a row of boxes. It's simply a row of boxes. Each of the boxes can store certain values, a single value. So just remember it in this way. Uh, when just imagine it in this way, that an array is a row of boxes. There are several boxes placed side by side in a row. Each of the boxes are labeled. That is, the first box has a label of 0. The first box is labeled 0. The second box is labeled 1. The third box is labeled 2, and so on. So the labeling starts from 0 and it increases by 1 at, you know, for every box that we move on forward in the row. So the first box starts with 0, and as we move on forward in the row of boxes, each box is numbered, 1 increasing. So it increases by 1 at every step. So that is basically, the concept of arrays that you are having trouble with. So it's nothing but a row of boxes, and these boxes can store certain values. So here it can store a certain value, here it can store a certain value. So these are separate values that can be stored in, the boxes. So there can be a certain value stored in this box, just like the boxes that you use in, in your daily life. So in the real world, just like you use boxes, so these are basically boxes, only that they are um, arranged in a single row. By placing them side by side, they are arranged in a single row, and you can store items in the boxes. These items are nothing but the values um, with respect to arrays. So an array is nothing but a row of boxes starting, and these are labeled boxes. Remember, it is a row of boxes, and the boxes are labeled starting from 0 and increasing by 1 at, once we move on to the next box, and so on. So this is basically the idea behind arrays, and we had also talked about the syntax. So this is basically the idea behind arrays. Now let's talk about the syntax, as in, if we are to implement this idea in our programming language, so what will be the syntax for that? So um, we had talked about two ways of defining arrays. So first way is when the values are known beforehand. So there's a way to define arrays when you already know the values beforehand. There's another way where you do not know the values beforehand, when the values are not known, or the user may input. User inputs values. So there can be two cases when defining arrays. The first one is when you already know the values beforehand, and the second case is when you do not know the values before, and the user will input the values when the user runs the program. So in this case, in the first case, uh, since you already know the values beforehand, so since you already know the values beforehand, so the size is also known, as in what will be the size of the array, how long will the row be, or how long will the array length be. So the so let's so the main point is that whether you know the values beforehand. So if you know the values beforehand, well and fine, you already know how many values are going to be there in the array. Therefore, you know the size of the array. In the second case, when you do not know the values beforehand, um, you either have to use, a sufficient value for the length of the array, as in the size. When declaring the array, you have to use a sufficient size. If by any chance the user, you know, uses more, or rather gives more number of values than the array size, then it will be a problem. But if the user is well within the array size that you have defined, then it will work well and fine. So let's see how both the declarations and definitions work for each of the cases. So for the first case, we just let's just define let's just work with integer arrays. So we can work with any data type. For convenience, we are working with integers as of now. So defining an integer array when we already know the values. So let's call the array int. Since we already know the values beforehand, let's say we have certain values -1, -5, 7, 9, 21. So these are values that have been already given to us, or we already know these values. So when we already know the values beforehand, this is the way to define the array, a new array. So I missed the third brackets here, so there will be third brackets. Let's just rewrite that portion. So int for brackets, for arrays, always use third brackets. This signifies that this particular variable is an array, followed by a space and the variable name, and then the equal to sign. And within the, when you know the values beforehand, so we specify the values within curly braces, and each value is separated by a comma. This is for the first case. So we have the data type, we have the array brackets. So these brackets signify that this particular variable is an array. We have the variable name, and we have the values separated. So each value is separated by a comma. Now, in case of the second, case, when we do not know the values beforehand, is one thing we need to make sure is that the size of the array is sufficient enough to hold all the values that the user may give, or we may get at a later time. So generally the user inputs values, so we need to make sure that the array size is sufficient to hold all the values that the user inputs. So let's call this array m. So the definition is a bit different. So the first part, again, as discussed in the previous class, the first portion before the equal to sign is same for both the cases. The difference lies in the portion after the equal to sign. So here we specify the size of the array. So size will be a number. So we'll be talking about size again. We have already discussed certain points about size, that we need to be careful about certain points when we define the size of an array. So we'll again do a quick revision of those points, but the basic syntax for the second case, when the values are not known beforehand, is this particular line. So first portion is same. We have the data type, we have the array brackets to signify this variable is an array, we have the variable name, and then we have the new keyword, again the data type, and within third brackets again the size of the array, as in the number of elements. So size is basically the number of elements in the array. There are two words which we will be using very frequently. One is elements, which stands for values in the array, and uh, at a later stage we will be using a word called key, where key stands for specific value in the array. So it will be much more apparent when we when we use this one. We'll be using this basically while discussing searching and sorting and all those operations on arrays. So just remember, for the second case, when you do not know the values that are to be stored in the array beforehand, you must define a sufficient size so that when the user inputs values, he does not run out of space. So let's say you declared the array of size 5 and the user inputs 6 values, then it will give you an error. So make sure you define the array with a sufficient size. There are certain points that you need to be careful about when defining the size of an array. So points to remember: when defining size of an array. So there are certain points that you need to remember when you define the size of the array. The first point is the value of size is always a positive integer. So integers can both be negative and positive. So the size value must always be a positive integer greater than 0. Preferably greater than 0. So an array with a negative size or a 0 size has no meaning. So the value of the size will always be a positive integer that is greater than 0. The value of size should be large enough to hold all possible values all possible number of values that the user may input. So the value of the size should be large enough to hold all possible number of values. Just as I told you before, if you have defined an array of size 5 and the user enters 6 values, then it will give you an error. So make sure that you define the size large enough to hold all the values that the user may input. You can do this either by defining a size that is more or less adequate enough to hold all the values that the user might enter, or you could directly ask the user to enter a certain number of values. So we generally use the second approach, but sometimes we might have to use the first way, where we assume a large enough size and we expect the user to stay within that limit. Otherwise you can just directly ask the user to enter um, values within the range or within the size that you have specified. So if you have defined an array of size 5, you'll just ask the user to enter 5 values. Similarly, if you have defined an array of size 100, we'll ask the user to enter 100 values, not more than that. So these are basically the 2 points that you need to remember. The first point is that the value of the size is always a positive integer and is greater than 0. So it will be starting from 1 up till, uh, it could be any number, but it should be positive. And it should always be an integer. It cannot be a fraction. So it cannot be a decimal number such as 2.5. So the array size cannot be 2.5. You cannot have two boxes and half a box. So you cannot store items in half a box, right? So therefore, array sizes do not, you know, they do not usually, rather they are not permitted to be fractions. So consider this idea behind arrays. So it is a row of boxes. So when we count, all of the boxes are whole boxes, right? One complete box. So you cannot have half a box or 1/4 of a box. It's of no use. You cannot store items inside, an incomplete box. So that's why it does not have fractional values. The size is always an integer. So that is all about, arrays and how they are defined, and that's all that you need to know about arrays as of now. So these arrays that we have discussed so far, these are called single dimensional arrays. So the arrays that we have talked about so far, so all the arrays, including the examples and the syntax, all the arrays that we have discussed up till now are called single dimensional arrays. So the arrays that we have talked about up till now are called single dimensional arrays. Why is it called single dimensional? Take a look at this picture. There's just one row of boxes, right? So an array basically represents a single dimensional array basically represents a single row of boxes. So this is a single dimension. So single dimensional. Why? Because there is just one single row. That's why it's called single dimensional. If it has more than one rows, so I could have more than, one row of boxes. So that signifies, you know, multi-dimensional arrays. So we'll talk about multi-dimensional arrays at a later time. As of now, just remember an array is a single dimensional array is a single row of boxes, or rather an array, the very basic form of array is a single row of boxes. That is nothing but a single dimensional array. On each of the boxes are labeled. So in the previous class, we had also talked about this labeling. There are two more points to remember in case of the labels. So let me write it down here. So these are basically labels that identify the box. So let me clear out the code and draw a fresh picture. So this is one box, this is another box, this is a third box, this is a fourth box, and this is a fifth box. So this is a single row of boxes, uh, the row is now there is a name for the row, so the variable that you define. So if I have defined int n is equal to new int 5, so that will look somewhat like this. So the name of the row will be n. So this is the row, the name of the row. This is a single row of boxes, which is the array itself. The row is called n, and the boxes are labeled 0, 1, 2, 3, and 4. So each of the boxes are labeled. So how do we identify each box uniquely? It's very easy. Just specify the row number, use the third brackets, and specify the label of each box. So this is the first box, or the first value of, so this is basically the first address of the first box. You could call this the address of the first box. So n of 0 within third brackets is nothing but the address of the first box in the row, or the first value of the array. So the first value of the array is nothing but stored in the first box in the row. So n of 0 is basically the address of the first box, or the first value, first location of the array. When I use n of 0 in my program, it will basically mean the value stored here. So let's call this value 1. So when we use n of 0 in this particular notation in our programming language, when we write programs, this will basically mean, or rather refer to this particular value that has been stored in the box labeled 0, or the location in the array labeled 0. Now we were talking about the labels. So the numbers that are on top of the boxes are called labels. Labels are basically, in programming, there is a term for these labels. So in programming, labels of the boxes are called indices. Of the array. So these particular labels that are 0, 1, 2, 3, and 4, which are the labels of the boxes, they are called indices, or index of the array. So this is the first index, or the first label, the second index, or the second label, and so on. So labels of boxes is equivalent to index of array. Okay, so remember it in that way. An array is nothing but a single row of boxes which are labeled. Each of the boxes are labeled, and each of the labels are equivalent to the index of the array. The first index is 0, second index is 1, and so on. So again, as I told you, there are 2 points to remember. So there are 2 points to remember with respect to index or labels. The first point, so index always, so from now on we are going to call the labels index. So instead of calling them labels, we'll call them index. To remember, just just remember it in your mind that so just to make a comparison, remember it in that way. So these are a single row of boxes with labels, and for programming purpose, for your program, remember that each of the box is a cell in the array, and each of the labels are called index of the array. So I'll write it down later. So first let us talk about the 2 points. So index always starts with 0, and it increases by 1 as we move forward. And as we move forward, which moving forward means in this direction. So this is the forward direction. So from left to right, as we move forward from left to right. So according to the example, an array, so this is just the, I'm writing the whole thing in words. So an array is a single dimensional. So we are talking about single dimensional arrays, so I'm specifying it within brackets. So an array is uh, like, so an array is like a row of labeled boxes arranged side by side. First point to remember, an array is like a row of labeled boxes arranged side by side. We are talking about single dimensional arrays. Second point, each box corresponds to a single element in the array. So each of the boxes can store a single value. That single value is called an element in the array in terms of arrays. The labels are called index with respect to arrays. Each label slash index identifies a unique box slash element in the row of boxes slash array. So the labels are called index with respect to arrays. Each label or index identifies a unique box or element in the row of boxes slash array. So row of boxes is equivalent to the array. Label of each box is equivalent to the index. So each box is equivalent to a single element in the array, and the label of each box is equivalent to the index of that element. Remember it in this way. So that is all there is uh, about the first topic. of today. So I hope the concept of arrays should be clear by now. So let us move on to the um, next topic, which is topic number 2, the for each loop. Okay, so before we move on to the for each loop, let us just write a simple program. So write a program to enter 10 numbers from the user. Simple program. So we have to enter 10 numbers from the user. So let's see how the program code will look like. So since we are taking user input, so we'll have an import statement. So import java.util.scanner. Now we'll have the class. Let's call it array1. Here we'll define an array. So we'll define the array as the class variable. We already know we need 10, so we are going to work with 10 numbers. That is basically the size of the array. So int, let's call the array n is equal to new int 10. So that's the size that has been given. So that's the definition of the array. We are skipping the constructor and directly moving on to the function that is going to take inputs. So I'm writing a separate function to take inputs, or rather to feed the array. You can call it feeding the array. So entering elements into the array may be called feeding the array. It will be a void function. Void, let's call it feed array. Does not take any arguments. Um, so I'll just ask the user to enter 10 values, or rather 10 numbers. So enter 10 numbers. Now I'll use a for loop. Again, this has been already discussed in the previous class, how to use for loops to work with arrays, how to use for loops. So for, I'll define the variable here itself. For int I is equal to 0. So I is basically the loop variable, but it controls the index number of the array. So I is equal to 0 since index starts from 0. I is less than 10. So index is always 1 less than the total size since it starts with 0. So you can count and verify that it's always less than the size of the array, 1 less than the size of the array. So you can count on your fingers. If it starts with 0, it will always be less than 1 the size of the array. So from 0, starting with 0, including 0 to 9, it will be 10 total elements. So now we are going to take inputs. So inside the for loop, we will just simply write n third brackets. So I is the index, the current index where the value is going to be inserted. So this will keep on increasing. So the first index will be 0. So n of 0 will get the first value that is being entered by the user. So one thing we missed here. So there's one thing that we have missed. Just hold on. So let me rewrite this thing. So we have forgotten to define the scanner class to take inputs. Since we are taking inputs inside this function, so we are going to define the scanner class here. So I forgot to define the scanner class. So scanner sc is equal to new scanner, the normal old definition that we have been using. Now we'll have an SOP, and now we'll have that same thing again. So since there was no space, I had to erase the whole thing and then rewrite it again. So enter 10 numbers. We'll have the for loop. We'll have the loop variable I, which is also controlling the index of the array, or the label of each box, if you may think with respect to boxes. Now this is how we are going to take the input. Just like we take inputs for normal variables. So in case of a normal variable, we write the variable name is equal to and this particular piece of code. So similarly, in case of arrays, the variable name is just replaced by the array name and the index. And the value of the index is controlled by the for loop. So for 10 numbers, this loop will run 10 times starting from 0. So from n0 up till n9, n of 9, it will take input, it will just keep on storing the values inside the array. So let us do a few dry runs to see how it works. So when I is equal to 0, we have n of 0 and the user enters a value. So once I have displayed this message, the user will start entering values. It is already inside the for loop, so the first value that is entered will be stored in the address n of 0. So the first value is stored to n of 0. So this particular line, when it gets executed, so n of 0 receives the first value that the user inputs. Now we move on to the increment statement here. So it increases the value of I from 0 to 1. So I is now 1 for the next iteration, which is obviously less than 10. Now we come inside again. Now it becomes n of 1. So it stores the second value. It goes back to the increment statement. I is now incremented to 2. Checks whether it's less than 10. Yes, it is less than 10. So I check it here. So 2 is less than 10. Again, I come inside the loop. So n of 2. So I is now 2. This stores the third value. So in such a way, I'll be equal to 9. N of 9 will store the last value, and when again it goes to the increment statement, I will become 10. 10 is not less than 10 and it will exit the for loop. That's the dry run of the for loop. So if we consider the image, so I'm not drawing all the 10 spaces. So 1 2 3, so 1 2 3 4 5, and in this way there are 10 boxes. So I'm not drawing all the boxes due to space limitation. So the first value is stored in, so this is the row that is called n. So the array name is the same. So the array name is basically the row name if you consider with respect to the example of boxes. The first box is labeled 0, which is the index of the first box. 1, 2, 3, 4, so on up till 9. So the first value gets stored here, the second value is stored here, the third value entered by the user is stored here, and so on. That's how it works. So now that we have already finished writing so now that we have finished writing the function to take input, so in the program we have only been asked to enter 10 numbers and do nothing else. So we'll just take inputs and we are done. So this function ends here. Next we'll have the main function. So we are writing the main function in the same class. Public static void main, the same old definition of main. So inside main we are not taking any inputs, we are just creating an object of this class. So the class name is array1, object is called obj. So array1 obj is equal to new array1. This is the default constructor. Now we just simply do obj dot feed array. The function does not take any arguments, and that's all. So, and that's the end of the class. So this is the complete program. I have a class, I define the array as a class variable, I write a function to input elements into the array or values into the array. Then I have the main function. Inside the main function I just call the I just create an object of the class and call the respective function to take inputs into the array, and that does my job. So this is basically how you will be taking inputs into an array. This will most of the time remain the same, just certain values will change. So this is how to take inputs into the array. This is basically the code of how to take inputs into the array. This will always remain same, only certain things will change, such as the size. This might change depending on the question. Size value might change. This particular thing might change depending on the data type of the array. So if it is a string type array, this will be string. So this will basically be accordingly. So there will not be int, just sc.next. So in that way, so this particular line, this portion of this particular line will change, and this particular value of the size of the array will change. Other than that, the rest of the function to take inputs into the array remains the same. This particular thing will change. Let's say this particular whole line shall change. You can try some other message that you might want to display to the user. But apart from this line, this particular value, and this particular line, the second part of this particular line, everything else remains the same inside the function to take inputs into the array. So I hope the process of taking inputs or feeding arrays is pretty much clear after this. So again, this value might change depending on the size specified. So that there are short changes, but basically the rest of the thing remains the same. So you can reuse this particular code for every array program, uh, cons- considering single dimensional arrays. For multi-dimensional, it's a whole different story, but for single dimensional arrays, this will always remain the same. The method to, you know, take input for the elements of the array. Now, considering the previous question, that the previous program that we just did now, so let's say I have one more question where it's the same as the previous question with just a simple modification. So write a program to input 10 numbers and display them. So the new addition is displaying. So I'll have a new function to display the values. The rest of the program will remain as it is. We are inputting 10 numbers again, size remains same, data type remains same. The only addition will be a display function. So I'll just be writing the display function. So I'm not writing the whole class again from the beginning. So let's say this was the feed array function that was taking inputs into the array. So the feed array function will basically be the same. I'm not writing the function. Same, it will be the same as the previous program that we just did. I'm directly going to the display function. So void display. So before this, everything is same. I'm just writing, I'm just showing the feed array function to, make it clear where you have to write the display function. So just after the feed array function, you'll be writing the display function. Inside the display function, you'll again have a for loop. You'll have the same format again. So it will start from 0, the loop variable. It controls the index also of the array. Will run up till less than 10, just like it was in the feed array method. And now we'll just have SOP. The array variable was n, so n of I. So this basically displays the value stored at this particular location, plus I'll just be, since I want to display it side by side, I'm using SOP, and I'm printing a space after every element that is displayed. And that is the code for the display functions. This particular function displays all the values inside the array. It's pretty easy. So the for loop syntax is pretty much the same as that of when we are using, to feed the array or input elements into the array. So this particular line will always be same when we are traversing an array. So to move around in an array, I'll always use something like this. So this particular line will always be same, only this particular value might change. And when displaying, we'll just display it like this. So we'll use SOP instead of SOPLN, and we'll display by specifying the array and the index, which is the loop variable. So again, if we dry run this, let's just look at a few dry run values. So when I is equal to 0, 0 is less than 10, so it comes inside the for loop. Now we come to the SOP statement, so it displays, so the output, so it displays the value of n of 0. So there will be a certain value inside this. Okay, let's take a short example. Just for the sake of explanation, I am changing this to 5 as of now. I'm taking an example. Let's say I have this array of size 5. The feed array method has already entered certain values. Let's say 2, 3, 5, 7, 10. These are the values that has been entered by the feed array. This is the array called n. These are the indexes or indices of the array, or rather the elements. So when I is equal to 0, I get the output. So when I run the SOP statement, I get an output of 2 and a space. So this b slash is basically the represents space in case of programming. So now we go to the, after this SOP statement is executed, we go to the I++ statement, increment statement. So I is now incremented to 1. So we take a look at n of 1. So what is the value at n of 1? 3. So 3 gets printed and a space after the SOP statement is executed. Now we go to the increment statement again. Now I becomes 2. We come inside, since 2 is less than 5, we come inside the loop. Now when SOP is getting executed, again we take a look. N of 2 has a value. So the value at the position n2 is 5. So n of 2 is 5. So the n of 2 is the address and the value at that address is 5. So 5 is printed and a space is printed. SOP is executed. We go to the increment. I becomes 3. We come inside, since 3 is less than 5. N of 3 has a value of 7. So 7 gets printed and a space. Go back to the increment. I is now 4. 4 is less than 5. Therefore we come inside. SOP gets executed. N of 4 has a value of 10. So 10 gets printed and a space gets printed. We go back to the increment. I becomes 5. 5 is not less than 5 and we exit the for loop. So we have the display like this. So omitting the, not writing the spaces, so we'll have something like this: 2, 3, 5, 7, 10. That is how we'll get in our computer display once we run this function. It's pretty simple. So let us change this value to the previous one. So what you will do at home is you will just copy the previous program, and just after the feed array function, feed array method, you will just write the void display method for this particular programming question. So this is another question, the first question with some additions. The addition is basically the display function, and again after the display function, the main function will be the same as it was in the previous program. So just copy down the main function again. Inside the main function, uh, you'll have this particular line, just like the previous program. New array 1. So this particular line is basically the same. Now you had this particular line, feed array, obj.feed array. After this, you'll just add one more line. So I'm writing the new line that is to be added in a different color. Just add this line, obj.display, just calling the display method, and the rest of the program is again the same. So this ends here, the class ends here. Just add this particular line and add this particular function to the previous program, and now you have a new program that takes input and also displays the values. So that is how you display elements or values inside an array. Again, in the display method, this particular value might change, otherwise everything remains the same as it is. Okay, nothing else changes except this particular value, which is the size of the array. Except that everything remains the same inside the display method. It's always the same. Whenever you display the elements of a single dimensional array, it will always be like this. Now coming to the second topic, uh, we'll probably be doing the second topic only today. The third topic, there's no time left for the third topic, so we'll cover the third topic in the next class. But let me just talk about the second topic. Second topic is pretty easy and it's not that big. So what I was going to talk about is the for each loop. The for each loop is basically, applicable to this display method. So when displaying, or rather when accessing the, values that have been stored in the array. So in display, we are basically accessing the values that have been stored in the array. So there's a shorter way of writing this for loop. That is nothing but the for each loop. So let's take a look. So if you take a look here, so for each loop is a version of the for loop itself. So it is used exclusively to loop through elements in an array. As I told you, to access the elements in an array, we use the for each loop. It's pretty easy. This is the syntax. So for, so let me write it down with respect to this particular program. So instead of this for loop, you can write for int I and the name of the array, which is n. Inside the for loop is the same. This particular thing remains the same. SOP. Now I'll just display I. Instead of n of I, I'll do I plus. So this is a shorter way of, writing this particular for loop. So for int I, we give a colon and we write the name of the array. So this is the array name. The array variable, and we simply display the value of I. What happens is in this particular code is that this whole thing is done internally. This whole thing is done by this particular code. So this whole operation is done by this particular code, and instead of using the array name to access, so I'm directly picking up each value, storing it in I, and then using I to access the values. So the for each basically stands for, so the above example can be read like this: for each int element, so for each int element I in the array, print out I. So again, if we consider a smaller example, let us consider an array with 4 elements, 1, 2, 3, and 4. So let's name it n. It has index number 0, 1, 2, and 3. So we are considering a short array for convenience. We have certain values 5, 7, 2, and 10. When running this particular for loop, what happens is for when this particular line gets executed, so for the first iteration of this for loop, this particular version, for the first iteration, I is equal to n of 0. Directly, this happens internally. So instead of n of 0, what happens is I get the value stored at n of 0. So I is equal to the value stored at n of 0, which is 5. I come inside, I display the value 5 with a space, go back to the for loop, and this automatically runs until the array ends, until we reach the end of the array. So everything is done automatically. So this whole operation of starting with the first value, incrementing, running up till the array ends is done automatically by this particular piece of code. So in the first iteration, I take out n of 0, the value stored at n of 0, store it in I, display it using the SOP. In the next iteration, I move on to the value of next location, that is n of 1. So I now has 7. So this is the first iteration. This is the second iteration. So I now has 7. Again, SOP displays the value of 7 with a space. Again, in the third iteration, we move on to the next value, n of 2. I now has 2, displays 2. And in the fourth iteration, I will have n of 3, which is 10. So I directly has the values of the locations. So instead of this n of I, which corresponds to the value, I directly take the value itself into the variable I in this particular for loop. In this particular for loop, I directly take the value of the array and I use that variable where I have taken the value to display the values. Okay, both of them basically do the same thing. This particular method you may or may not use depending on your preferences, but during exams you will be using this particular version. So this version of the for loop will be used during exams. They might ask you, if they'll particularly specify if you have to use for each, or they might ask you in objective type questions how to use a for each. Let's say they'll give you a for loop, they'll ask you to convert it into a for each loop. So you'll basically get objective type questions. So objective questions from the for each loop part, and while writing programs you'll be using the extended version of for. So that is basically the for each loop, a shorter version of the for loop, which is only applicable in case of arrays. We cannot use it for normal variables. So it's a pretty shorter version of the loop that we use to traverse arrays. So the for each loop is a shorter version, and it basically, they'll ask you objective questions from the for each loop. So that's all for today's class. The third topic still remains. So searching, I'll do it in the next class. Just revise how to take inputs and how to display the elements of an array, and searching elements in an array, we'll be covering it in the next class.